Hello, good morning. In the previous class, we had completed the first unit, and in this class we will start unit second, that is the entropy. So this is the new concept. So we have to understand the concept of entropy. So this concept of entropy was first introduced by the Rudolf Clausius in 1865. This entropy concept is introduced by the Rudolf Clausius in 1865. Okay, so this we already know the name Clausius Clapeyron. So this is a Rudolf Clausius in 1865 introduced the concept of entropy during his work on the formulation and applications of the second law of thermodynamics. We will see the first law of thermodynamics in the unit first, and unit second we have to study second law of thermodynamics. So it is the important law because this law is totally depend on the first law. So that's why it is a very important thermodynamic quantity. So this entropy is the very important thermodynamic quantity and has proved that this is to be very useful in the study of behavior of heat engine. So we already studied the Carnot ideal heat engine. So in that ideal heat engine we also introduced the concept, introduced the entropy, but simply it is the word entropy. But in this chapter we will totally study about the entropy. What is entropy, what is the concept of entropy, how it is used, how it is very important. So that's all these topics we have to cover here in the unit entropy. So in order to describe the condition of a working substance, so we already use a thermodynamic variables, that is the pressure, volume, temperature, okay, and the composition. These are the four variables we have to use to describe the conditions of any working substances, okay. So the Clausius felt that the need of another variables of state in addition to volume, temperature, pressure and internal energy, etc. So this new variable is called the entropy. This is the fifth one because we already studied four types of variables, means five types of variables, pressure, volume, temperature and internal energy, and in addition to that the new concept was the entropy. This is the new variables and this is the very important variable, that is the entropy. So thus entropy can be defined as, according to this to describe the working substance we have to use this concept, that is the entropy. So according to this, the definition of entropy is the thermodynamic property of a working substance. It is the property of thermodynamic property of working substance. That's why thermodynamic property of a working substance which remain constant. This remain constant during an adiabatic process. Okay, we already know the adiabatic process. Adiabatic process means the energy neither be stored or gained, given to it, or neither be removed. Means the energy remains constant. So that type of property is known as the entropy. So definition of entropy: the thermodynamic property of a working substance. This is the property of working substance. This is the property of working substance. Okay. So this is the property, thermodynamic property of a working substance which remain constant. Which remain constant during an adiabatic process. Okay, adiabatic process means what? When no energy given to it or removed from it. So this is the definition of entropy. The thermodynamic property of a working substance which remain constant during an adiabatic process when no energy given to it or removed from it. So this new concept is called the entropy, and this is introduced by the Rudolf Clausius in 1865. Okay, so then next one is the concept of change in entropy. How we can study about the entropy, that is the next concept, change in entropy. Okay, change in entropy. So for that we have to draw a diagram, and this diagram is, so let us consider a number of isothermals. So we have to draw a diagram. So consider here the number of isothermals, that is T1, T2 and T3, and this shown in the PV diagram. We already know PV diagram in the unit first, pressure volume diagram. So these are the three isothermals, T1, T2 and T3, drawn at the small but equal temperature differences bound by the same two adiabatics L and M. So these three adiabatic bounded by the two, so these three are the isothermals bounded by the two adiabatics at the same temperature differences. So these are the two adiabatic L and M, and the difference between these two isothermals are small but same. These two differences are the same differences. So we write here point A, B, C, D, E and F, and the functioning here. So this is the Q1 amount of heat, here the Q2 amount of heat and Q3 amount of heat. Okay, so this is the diagram to understand the concept of change in entropy. Okay, so this diagram, according to this diagram, all along the adiabatic L and M there is a change in volume and temperature with a change in pressure. Means there is a change in volume and temperature here along this adiabatic L and M. There is a change in volume and temperature, and along due to pressure and volume changes according to temperature. Okay, so let us consider, let A, B, C, D. Here A, B, C, D. Here the one Carnot cycle, reversible cycle, and here C, D, E, F are the second reversible Carnot cycle. Okay, so this is the reversible cycles. So first of all we see the, during this reversible cycle A, B, C and D. So observe this diagram. So in this, so during the reversible cycle, A, B, C, D. Okay, so see this, here Q1 amount of heat is absorbed in going from A to B by the source. Okay, here Q1 amount of energy or Q1 amount of heat is absorbed by the source in going from A to B at the temperature T1. Okay, and next in going from C to D, Q2 amount of heat is rejected by the rejected to the sink at temperature T2. Okay, so we already know the functioning of this Carnot cycle ABCD. So we take here shortly, Q1 amount of heat is absorbed by the source in at temperature T1 in going from A to B, and Q2 amount of heat is rejected to the sink at temperature T2 in going from C to D. So therefore, so then according to Carnot theorem, the efficiency of Carnot engine, according to Carnot theorem, the efficiency of cycle ABCD is given by eta is equals to Q1 minus Q2 divided by Q1. Okay, efficiency of the cycle ABCD is given by, or the Carnot engine is given by, eta is equals to Q1 minus Q2 divided by Q1, or we can write at temperature T1 and T2, that is T1 minus T2 divided by T1. So we can write here Q1 by Q1, that means 1 minus Q2 by Q1 is equals to 1 minus T2 by T1. Or we can write Q2 by Q1 is equals to T2 by T1. Okay, so therefore Q2 by T2 is equals to Q1 by T1. So we can write, or here we take first Q1 by Q2. So we here write Q1 by T1 is equals to Q2 by T2. This is the first for the first cycle ABCD. Okay. Then in going from cycle CDEF. So during the cycle CDEF, okay, so see this CDEF, here Q2 amount of heat is absorbed by the source at temperature T2 and Q3 amount of heat is rejected to the sink at temperature T3 in going from C to D and E to F. So therefore the efficiency eta is equals to Q2 minus Q3 divided by Q2 is equals to T2 minus T3 divided by T2. So we can write 1 minus Q3 by Q2 is equals to 1 minus T3 by T2. So after conversion we can write here Q3 by Q2 is equals to T3 by T2, and we can write Q2 by T2 is equals to Q3 by T3. So this is the second number equation. Okay. So these are the two equations. After that, so comparing this equation 2 and 1, or from equation 1 and 2, we write the change in entropy, that is here Q by the next one, from equation 2 and 3 we write Q1 by T1 is equals to Q2 by T2 is equals to Q3 by T3 is equals to dash constant. Okay, so this is the next one equation number 3. So the mechanism of this change in entropy we will see in the next class. Thank you.